always a 90-degree angle, doesn't that mean that the other two angles have to be acute? Because they're gonna have to add up to give you that 180 degrees. So they're just saying if it is, okay, well, there is no other option. It can't be a right angle, which means that it is going to always be an acute angle. So please don't get hung up on that word. But we also know sine is 4/7, and I was asking what are the other 5 trig functions. So this one, we drew our own triangle. You can draw any right triangle you want. I tend to draw them always the same, at least as far as the way they're oriented, but you could have it literally flipped any way you wanted. Place theta in one of the missing angles. So again, not the right angle, but either of the others doesn't make a difference. We decided to put it on the bottom. And if I'm telling you that the sine of theta is equal to 4/7, aren't I telling you the opposite of hypotenuse does? Because I'm telling you sine, well, sine is always opposite of hypotenuse, which means that's what those two numbers mean. So the opposite is going to be 4, the hypotenuse is going to be 7. We use the Pythagorean theorem to figure out this missing side, which was the square root of 33. No decimals. Okay, we're keeping things in radical form. I don't want any decimals whatsoever. So I don't even want you to actually divide out 4, divide by 7, give me decimal format. Do math, enter, enter, reduce it, but that's as far as I want you to go with it. So we went through the exact same process, figured out these answers, but there was a problem with these two. You are not allowed to have a radical in the denominator. So even though 7 over the square root of 33 is the correct answer for the secant of theta, that's not the way that we would ever see that. We would have to look at it in a different format. So down here, I showed what we were actually doing.